Hi, it's Loren again. I'm a tutor for the Center for Academic Success, and I'm here to talk to you about a common question I get when I'm doing assessment tutoring. And that question has to do with standardized scores. A lot of times students are in class and they're learning about standardized scores, or they take an exam that asks them to calculate what percentile rank a certain score is, and they come to me for help with that. Unfortunately, when I point them to like a book like this that has sort of like the bell curve, and it has a bunch of standardized scores and the percentile ranks, often students find that overwhelming, like they have to memorize everything that's on this table. So what I'm here to talk to you about today is you don't have to memorize it. If we can understand the normal curve and the z-distribution and z-scores, you can actually very easily calculate any percentile rank if you know a certain score. So that's what I'm going to be showing you today. Have you ever been studying for assessment and ran across a page something like this? It's like a bell curve, and it has like IQ scores, T scores, and so forth. You have all these percentile ranks, and it's like, how am I going to memorize all that? Well, the good thing is you don't really have to memorize it, because it is all based on the normal curve. Actually, it's based on the z-distribution. And if you know the z-distribution, you'll know all other scores and their percentile ranks, and you don't have to go memorizing them. So if you remember from introductory statistics class, you know the normal distribution is based on the z curve. And the average or the mean is right here in the middle of the curve. And when you think of a z curve or z scores, the mean is at 0. If you also remember about z curves or z scores, they have a standard deviation of 1. So one standard deviation above the mean for a z-score or a z-curve is +1. 2 standard deviations would be 2, and so on. We can also go the other direction on the curve, where we could have -1 standard deviation, -2, and -3. Now, if you look at the z-curve, you can think of it also as the proportion of scores that fall underneath the curve. So you know at the mean, or at a z-score of 0, it's the 50th percentile rank, because 50% of the scores fall below the mean. This part requires some memorization and sort of remembering how many, what percentile rank each standard deviation is above the mean. So like one standard deviation above the mean would be the 84th percentile rank. 2 standard deviations above the mean, or z-score of 2, corresponds to a percentile rank of 98%. And then +3 is like 99% or even greater than 99%. Now, if you know this direction, you automatically know this direction by doing a little bit of math, because the normal distribution is perfectly symmetrical. For example, we know that +3 standard deviations above the mean, or a z-score of 3, is at the 99th percentile rank. If we take 1 minus that, we get the 1st percentile rank down here. Okay? And we can just kind of work our way across. If we know +2 standard deviations is the 98th percentile rank, or a z-score of 2 is the 90th percentile rank, we could do 1 minus that, and we get the 2nd percentile rank. We could do the same thing for the 84th percentile rank here, for +1 and -1 standard deviations, or z-scores of +1, -1, and we get the 16th percentile rank. All standardized scores, or most standardized scores, are based on this distribution. And you can figure out the percentile rank of any standardized score by knowing this. If you remember, the formula to figure out a person's or an individual's z-score is z is equal to the person's score minus the mean over the standard deviation. So for example, we know that the Wechsler IQ tests have a mean of 100 and a standard deviation of 15. If we had a person score 115 on the Wechsler scales, we would say, okay, well that person's score is 115 minus the mean of the Wechsler scales, which is 100, divided by the standard deviation of the Wechsler scales, which is 15. If you do this, you'll get a score of 1, meaning that the person's score falls right here, which is the 84th percentile rank. You could do this for 130 on the Wechsler, which would be the 98th percentile rank, and so on. And you could do it down this way too. This just doesn't work for the Wechsler scales. It works for T-scores. For example, the MMPI uses T-scores. The T-scores have a mean of 50 with a standard deviation of 10. And you can use the same algorithm to figure out percentile ranks there. So this video is just to show you that if you know the Z-curve really well, the normal distribution really well, and you understand the percentile ranks that go with it, you can figure out any person's percentile rank by using this little formula here. Hopefully this will help you when you're conducting assessments, it'll help you in your assessment class, and it'll help you on assessment exams. Thanks for watching.